Hi, this is Rich, and in this video we're going to take a look at the Unmanned Aerial Vehicle Navigation Subsystem. So how does an unmanned aircraft system know and change the UAV location? Unmanned aircraft system subsystems are designed to interact with the environmental conditions to maneuver the UAV to the desired location or fly a specific pattern. In this section, we'll focus on how the UAV navigation subsystem manages flight using information about aircraft location, position, and movement. The UAV navigation subsystem must answer three questions to make navigation possible. First, where is the UAV's current location? Two, what is the UAV's current position and movement? And finally, how and where is the UAV moving to? So how does the UAV determine its current location? So really we can think about three methods of gaining a UAV's location within the entire UAS. When we include the operator, we can see that the first method is something we probably initially can all imagine, and that is just direct visual contact between us or the operator and the aircraft itself. Now, as long as we can clearly see the aircraft, its orientation, the surrounding airspace, and other aerial hazards that the aircraft might encounter, then we're good to go. We really don't actually need a quantitative coordinate to actively use and effectively use the aircraft. Our second method would be using the first-person information from onboard video. So there we can either use our location that we can see from the aircraft or use other identifying features on the landscape such as terrain or other structures to identify where the aircraft is looking from. So understand that perspective by watching the video and then figure out where that aircraft is located. Now, as long as we can see the home position location or the location where we are, then we have a safe path back to the launch location to recover the aircraft. And finally, the UAV location systems. So here, the UAV location systems are going to provide quantified XY coordinates in some sort of coordinate system. The global navigation satellite systems are a series of satellites and receivers that provide satellite-based locational information via a coordinate system for objects anywhere on or near the Earth's surface. Onboard GNSS receivers provide a UAV's location in the X, Y, and Z dimensions. You can see the graphic to the right demonstrates a simple Cartesian coordinate system. Several GNSS exist in space, orbiting Earth, created and maintained by multiple national efforts. Most modern UAVs can receive locational services from multiple GNSS. For example, most DJI aircraft receive locational information from GPS maintained by the United States and from GLONASS maintained by Russia. What is the UAV's current position and movement? So UAV position is defined as the attitude, orientation, and altitude of the UAV at its current XY location in the coordinate system. The UAV uses a number of digital elements to describe the UAV position. Gyroscopes use a series of gravitational sensors to determine UAV attitude along the pitch and roll axes. We talked about GNSS in the previous slide, providing precise information in the X, Y, and Z dimensions. Magnetometers are just digital compasses which allow the UAV to always know which way is north. And finally, accelerometers determine the rate of movement in all 365 degrees. I encourage you to check out the videos that describe how each of these components work. So this brings us to the third question the UAS must answer in order for navigation to be possible. Two navigational subsystem devices determine where and how the UAV will move. The flight controller is the navigational hardware, and the autopilot, the navigational software. The flight controller is essentially the brains, the onboard brains of the UAV. It takes information from the sensors we've already discussed makes some decisions about where the aircraft needs to go with the help of the autopilot, and then provides power management in the output via electronic speed controllers and other navigational servos to steer the aircraft to its next destination. So how exactly does the flight controller move the unmanned aircraft vehicle? Well, in this case, we have to break it down by both multi-rotor and fixed wing. So for a multi-rotor, the flight controller uses what's called an integrated propulsion method, where the computer on the flight controller determines the required altitude and attitude to meet the navigational objectives. The flight controller then regulates power output to each of the motors in the electronic speed controllers to adjust aircraft attitude and navigational speed. With a fixed-wing aircraft, ESCs only control the propulsion portion of movement, while servos will adjust ailerons, stabilizers, and rudders to maneuver the aircraft. So the autopilot provides autonomous navigational control of the UAV by guiding the flight controller through a series of conditional waypoints. The autopilot guides UAV by the way of ground control station software. And finally, I just want to talk about a few other objects that UAVs use for conducting some navigation. The inertial measurement unit is an optional collection of sensors that provide precision, position, and location information for advanced or more expensive UAS. Laser altimeters and optical sensors can be added to provide high precision elevation information, as well as information about 3D structures and environments that the UAV can operate even inside of, such as rooms and buildings. Barometers can be also added to UAVs to get very precise or redundant measurements of elevation. And sonar systems are used, are popular today, especially within DJI aircraft, for collision avoidance and for aid in precision landing. And finally, the optical snapshot. Some UAS come with the capability of taking a snapshot at the time of launch and then using that visual information for a precision guided landing during recovery.